Welcome to our channel. In this video, we focused on optimizing train maintenance scheduling. Our goal is to demonstrate the feasibility of using simulation to improve overall maintenance efficiency. It involves managing the manufacturing and maintenance of 26 trains. Manufacturing process. Each of the 26 trains takes 3 days to manufacture. Starting from the day of manufacturing, one train will arrive at the maintenance bay every 3 days. This cycle continues to align maintenance activities with the manufacturing timeline. Maintenance plan. The maintenance schedule includes routine checks every 3 days and comprehensive overhauls once a year. The maintenance window is limited to 5 hours 30 minutes daily, starting from midnight to 5:30 a.m. After this time, the trains will be used for passenger transport. Service times vary between 10 minutes and 10 hours. If servicing is not completed within the day, the remaining service will be carried out the following day. The process involves balancing operator availability with the limited number of platforms. There are 8 platforms for repairs, 4 for the upper and lower regions of the trains, and 4 additional platforms for the lower regions. Additionally, there are 29 parking platforms for trains when not in service. To address these challenges, we developed a virtual environment in FlexSim. This environment replicates the railway network and maintenance depots, incorporating key elements like train schedules, maintenance activities, and resource availability. The simulation focused on planned maintenance, allowing us to assess the impact of activities on train availability and resource utilization. Key performance indicators like maintenance turnaround time, train availability, and resource utilization were introduced. We also simulated varying resource levels, particularly mechanical and electrical operators, to assess their impact on efficiency and identify optimal staffing levels. The model was validated against the operational framework and refined based on their feedback. Various scenarios were tested to highlight bottlenecks and provide actionable insights for optimization. The expected outcomes include improved scheduling to reduce conflicts and downtime, optimized resource allocation, enhanced decision-making through data-driven insights, and a demonstration of feasibility showing how simulation can effectively address real-world maintenance scheduling challenges. Thank you for watching.